Hello again, everybody, and welcome back to the Independence Public Library's Science Time. Once again, I'm part-time scientist Mr. Alex, and today the experiment that we're going to be working on is about vortexes. Specifically, creating a vortex using two bottles. And if you're wondering what a vortex is, you might get this idea of like big swirling masses in space. That's what I always thought a vortex was growing up. But a vortex is really just any spiraling fluid that brings things into its center, swirling around and bringing it in. There's a lot of different kinds of vortexes out there. If you think tornadoes, if you think whirlpools, they're both different kinds of vortexes. A tornado in specific being a vortex of air and other particles, whereas a whirlpool is more like a vortex of water or liquids. They're both fluids, but they're different kinds. So today, the one we're going to be focusing on is the whirlpool end of that. We're going to be using mostly water inside here in order to create our own cool vortex. So what we're going to need to start off with is you're going to want to get two bottles. Generally, the bigger the better. This is just my example one, but you could go up to 2 liters or any other kind of size. You probably just want to make sure that they are the same size. Put them side by side. And then what you're going to do is you've got a lid on it, take the lids off of them. You're going to have one bottle here, another bottle in this hand. You're going to flip it on top, and you're going to have the entrance from one go into the entrance of the other. And then it's just as simple as taping the whole thing up. When I said this was a simple experiment, I really meant it. This is not a very difficult one to do. Although, if you've got an adult who can help you, then what you can do to make this work even cooler is you can have your helpful adult cut out a hole out of both of the caps that you're starting with and screw them on, and then put them together, and then using really, really strong duct tape around to connect the two. And I'll show you the end result right here. Voila! Look at that. So we did the same thing. I cut out a hole from the cap right here on both of them, and then I attached them on the bottles, stacked them on top of each other, and then using really, really, really strong duct tape. You're going to want really strong, heavy-duty tape to keep it from leaking. I connected them together. Now it's like this. And before you tape it together, you're going to want to fill up one of the bottles to about 2/3 of the way up with water. I also put a little bit of food coloring in just to make it, a bit more exciting to look at. A cool blue. And so now, if we remember what the definition of a vortex is a spinning fluid that brings things in, like a tornado or a whirlpool. So in order to do that, we can flip this over, and making sure that wherever you are, it's okay to get wet just in case you didn't seal it well enough. And then we're going to give it a spin, and you should see the vortex take shape. Wow, pretty cool, huh? Look at it go. Voila. All the way down at the bottom. And so what we did by spinning it is we kept the liquid going in a certain way, and it kept this little whirlpool that we created that sucked everything downwards through the hole that we've made and into the other bottle. And then we can flip it and do it over and over again. But something that was cool to experiment with is, let's compare it to if we just flip the bottles but we don't spin it. What happens if we don't make a whirlpool? What happens if we just flip it over? Let's take a look. That's going pretty slow, huh? Wow, why is it taking so much longer than if we spin it? Yeah, that became so much faster after we started spinning it and created a vortex. Why do you think it is that the water moves through one bottle to the next so much faster with a vortex compared to just flipping it over? Well, there's actually a really cool reason for that. Now, if you look at this, you might think at first that it's mostly empty. Look at that. There's like nothing in there, right? Like all the water's down here. There's like nothing up there. But that's not completely correct. There's actually air up there. And while we can't really see air most of the time, and we don't oftentimes think about it being there, air is stuff. And so the problem is, if we flip it over, like this, the air is in the way of the water trying to get down. So as the water goes down and tries to get in to the other cup because gravity is pushing it down, air has to find some way out, or else, the water can't come down. And that's what these little bubbles are. The bubbles are the air coming up. So effectively what we're seeing is when we do it like this, the water and the air have to take turns going through this narrow little gap. So it lets a little water in and an air bubble comes up. Little water in, air bubble comes up. Little water in, air bubble comes up. And that's why it's this little glug, 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 glug thing that we've got going on. When we've got a vortex, though, a whirlpool, we create a constant spot in the center where the air can keep coming up, because the water's not going straight down. The water is going down and around and leaving this big circle in the center for the air to come through. So the air and the water doesn't have to take turns. The water can keep going and the air can come straight up through the center. And if you take a look from the top, you can really start to see that circle. So I definitely recommend that you get a good look at all different angles when you make your own. But there you have it, everyone. Your very own bottle vortex that you can make at home with very few materials and only a little bit of time. But there's a whole lot of cool experiments you can take with it. On that note, thank you for joining me for this Science Time, the Independence Public Library. We hope to see you next time. Take care and have a wonderful day.